Hello again and welcome. We're going to be continuing on with the 2011 Cimc, that's Canadian Intermediate Mathematics Contest. We just finished the first question in Part B, that's the written justification style questions. So we're going to be continuing on with question number 2 in this video. So let's take a look. So a pattern of figures is shown below. 1, 2, 3 figures. Figure 1 is a regular pentagon with side length 1. So this figure right here, side lengths are 1. Figure 2 is a regular pentagon of side length 2, drawn around figure 1 so that the two shapes share the top vertex T, and the sides on either side of T overlap. Alright. The pattern continues so that for each n greater than 1, figure n is a regular pentagon of side length n, drawn around the previous figure so that the two shapes share the top vertex T, and the sides on either side of T overlap. The ink length of each figure, okay, so we're defining something new, is the sum of the lengths of all of the line segments in the figure. Okay, so each side length here is side length 1, so 1, 2, 3, 4, 5, ink length is 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, ink length of 13. Each of these longer ones is a side length of 2. This is a length of 1, so this will have to be a length of 1 to make the whole length 2. Okay. Basically, we can copy this little interior diagram is 13. We don't need to recount it. 14, 15, then plus 3 for the side length there. So that's 18 plus 3, that's 21, plus 3, that's 24, ink length 24. Okay, so I think we got a handle on the definition of what an ink length is. So we are asked to determine the ink length of figure 4. Okay, probably best just to draw it out and determine the ink length that way. So we get ourselves another piece of paper, and we start drawing. Oh, I'm on blue for some reason. So pentagons aren't the easiest thing to draw, but that's okay. We'll make this vertex T up here. So there's figure 2. So to get figure 3, we just need to extend this line here, extend this line here. And we're asked about figure 4, so we extend it one more time. So we need to figure out the ink length of figure 4. So let's just label this guy figure 4. And we need to justify it. Okay. So as I remarked when I was talking about figure 3, we can, and we saw figure 2 was contained inside figure 3, we can easily see that figure 4 contains figure 3. So how do we figure out the ink length of figure 4? We just need to take the ink length of figure 3, which we already know, and we need to figure out what extra bits have been added to make figure 4. So, if we wanted to, we could actually use a bit of the blue, and we could redraw figure 3. Okay, so there is figure 3, and we'll just color code them in our explanation. So we need to figure out the ink length of the rest of the figure. Let's highlight that as well. We'll highlight it in red. So we need to figure out the ink length of the rest of the figure. Okay, well, we've reduced it to a much simpler problem. We're not counting up pentagons and overlapping little bits. We're taking what we know about figure 3. And what do we know about figure 3? We know figure 3 has ink length of 24. So we would just need to add that 24 on to the remaining ink length. Okay, so we just need to figure out the rest of this figure right here. So the larger pentagon, we should specify the larger pentagon, so this gives us 4 plus 4 plus 4 for the ink length down here. 4 and 4 and 4. Now about these two smaller bits, they each have ink length 1. As we can see, we note that this side length here is 3. This has to be 1 because the total side length, that's an awful brace bracket. The total side length is 4. Oops. So the red portion here has ink length 1 plus 4 plus 4 plus 4 plus 1. And that's quickly added up to be 14. I guess we should label this in blue as well. And figure 3 has ink length 24. So figure 4 has ink length 14 plus 24, and that's equal to 38. Okay. So not only that, we've sort of hit upon an interesting way to generate the ink length of figure 5. We would just need to take the ink length of figure 4 and then calculate this difference, this extra little bit, which looks like it'll always just be 1 on one side, then the length of the figure, the length of the figure, the length of the figure, and another little 1 bit. Okay? So that's just something to keep in our back pocket as we continue the rest of the question. So that was part A. What is part B asking us? Determine the difference between the ink length of figure 9 and the ink length of figure 8. Okay. So we probably shouldn't draw these. They're probably going to get rather big. So we're going to need to reason. We're going to need to make an argument. We're going to use another color as well for figure 8. So let's draw figure 8, a little bit of figure 8, not the whole thing. So once again, we're asked to determine the area of this, the ink length of this little red bit. So how do we do that? Well, once again, we just note that the large pentagon has side length 9. So each of these guys is going to be 9. In fact, for any figure, it's always just going to be n. This little extra bit will always be 1, because this is 8, and the total side length has to be 9. 1, 8. So we have a length of 1. So the difference in ink lengths, oops, whoa. Clean that up a little bit so we can put these notes online. So 1 plus 9, that's 10, plus 9, that's 19, plus 9, that's 28, plus 1, that's 8. And we can make a little comment in case we'll need this for the next part. Three n plus 2. 3 copies of the side length of the big pentagon, which is n, plus 2 for those tiny little extra bits. So it's not hard to see from our reasoning that we can just generalize this to the difference between figure n and figure n minus 1. This might be necessary. If not, it's a fun little fact that we've added just so that we further explain to the markers we know what's going on here. So let's take a look at C part, which is the last part in this question. Determine the ink length of figure 100. Okay. So let's think here. How would we figure out the ink length of figure 100? We certainly can't draw it and count it all out. But maybe we can find a general formula for the ink length of figure n. So how about we try that, and then we can just plug in n is equal to 100. Okay. So what do we know about the ink length of figure n? Well, we don't know a whole lot. We don't even know what n is. N is just a placeholder here. But we do know, by our previous observation, the observation we made on the last page, the length of figure n is equal to the length of figure n minus 1 plus 3n plus 2. Okay, so now we know what the length of figure n is in terms of the length of figure n minus 1. So how do we figure out the length of figure n minus 1? Well, he's just the length of figure n minus 2 plus n minus 1 plus 2. So these guys together here make up the length of figure n minus 1, and we keep in this 3n plus 1 here. So we can keep going on and on and on like this. So we have the length of figure 1 plus, we want the length of figure 2 next, so 3 times 2 plus 2 plus 3 times 3 plus 2 plus all the way up to 3 times n plus 2. Okay, well, we know the length of figure 1. Right? That was given to us at the very start of the question. The length of figure 1, the ink length, is 5. So we can just plug that value in. Okay. Three times 2 plus 2 plus 3 times 3 plus 2. Let's bracket these guys together so we know that they come from sort of the same reasoning. They come from the same statement. Plus 3n plus 2. Now I noticed something really nice. 5 is 3 times 1 plus 2. So I'm going to plug him in. And now what I can do is I can group these plus 2's together on their own. How many of them are? Well, there's 1, 2, 3, 4, 5, all the way up to n. So there's going to be 2 times n many plus 2's. So I can group them all together as just 2n. And then 3 times 1 plus 3 times 2 plus 3, all the way up to 3 times n. That's just the same as saying 3 times 1 plus 2 all the way up to n. Okay. Now this guy here, this expression here, the sum of the numbers 1 up to n, he has a nice formula. It's a common formula. It comes up a lot on contest questions. He is n times n plus 1 over 2. Fantastic. Okay. So now, just in terms of n, we know the ink length of figure n. We've been able to express it in a nice closed form. None of this dot, 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 no ellipses. We just have a final formula that we can use. We could probably pretty this up a little bit more. You know, make this a 4n and somehow add it in here. But we don't need to. We have a formula. So the ink length of figure 100 is 2 times 100 plus 3 times 100 times 101 over 2. And we can grab our favorite calculator if we need to and work that out. So that's going to be 200 plus 3 times 5,050. So 200 plus 3 times 5050. Calculator, or if we wanted to, we could do it out by hand. Tells us that this is going to be 15,350. That's our final answer. So let's take a look. We've got the ink length of figure 100. Is that all we were asked to do? Absolutely it is. And we've written out our steps. We were able to come up with a formula by using sort of recursion and a remark that we made during our solution to the B part of this question. So we definitely explained everything away. We're ready to move on. That was a nice question, frankly. I really liked it. We're ready to move on to the final question, question number 3 in part B. It also required justification. If you like these videos, if you've been liking this contest so far, feel free to like the video, or even if you really like the math contest content, feel free to subscribe and you'll get updates when new videos are posted. But regardless of what you do, thank you so much for watching, and join me next time as we finish up the 2011 Cimc paper.